This is the scene you would witness upon reaching the edge of a black hole. Thousands of versions of yourself appear around you. This is not science fiction, but a real physical phenomenon. Because the gravity around a black hole is extremely strong, it forces photons to move at high speed along bizarre trajectories, thus forming the mysterious photon sphere. When photons from different directions re-enter your eyes, you will see multiple images of yourself. Soon you will be dragged into an endless abyss where even time and space become extremely distorted. Next, I will use hardcore physics to let you experience what exactly would happen if you were thrown into a black hole. Now we board a spaceship heading toward the black hole and stop at a relatively safe distance. I choose to stay in the cabin to control the spacecraft, while you put on a specially designed spacesuit and prepare to head toward the black hole. At the same time, you are equipped with a dual display watch, showing your own subjective time and my time on the spaceship. Because according to Einstein's theory of relativity, time and space are relative. Time flows at different rates for observers moving at different speeds. Due to the extreme distortion of spacetime around the black hole, 1 hour passing in your frame of reference may correspond to several years passing on the spaceship. The movie Interstellar perfectly demonstrates this time dilation effect. When everything is ready, you decisively jump out of the cabin and begin to be pulled by the black hole's gravity. Because the gravity of the black hole is extremely strong, it captures all nearby celestial bodies in matter. So you will see an accretion disk rotating around the black hole. But because it rotates at an extremely high speed, almost approaching the speed of light, under constant friction, the disk's temperature can reach hundreds of millions of degrees Celsius and produce intense and deadly radiation. At the same time, you will also observe the Doppler effect. Light from one side of the disk will appear brighter than the other. Because the material in orbit is moving extremely fast, one side is rapidly approaching us, causing all light waves to be compressed together, allowing us to receive higher frequencies, while the other side is rapidly moving away from us, stretching the light waves, thus resulting in lower observed frequencies. At this moment you check your watch, and find an 11-second discrepancy between you and the spaceship. Soon after, you notice the starlight ahead appears slightly bluer. This is because the black hole distorts the surrounding spacetime, slowing the passage of time. So from your perspective, light from distant stars seems to be speeding up, resulting in a blue shift. You will also witness a strange aberration of light. The black hole seems to be drifting away from you. As you continuously move closer to the black hole, light in front of you keeps compressing, squeezing your forward field of view. You check the watch for the second time, and find the time difference has grown to 44 seconds. As you continue to accelerate toward the black hole, by constantly chasing the light ahead, the view in front becomes increasingly bright, while light from behind struggles to reach you, so it becomes darker and darker. At this moment, when you look back at the spaceship in orbit, you will find its motion gradually slowing down, because every signal emitted by the spaceship takes longer and longer to reach you. You then realize in shock that the time difference has reached 3 hours. The gap in time becomes increasingly obvious. As time goes on, the moment you pass through the accretion disk, the disk seems to vanish from your view, because the gravity here is so strong that all matter within this distance can no longer maintain a stable orbit around the black hole, and instead begins to spin rapidly and fall inward. 2 minutes later, you reach the photon sphere of the black hole. Because space-time distortion here is extremely severe, photons are briefly trapped in special orbits at high speed, allowing you to see multiple overlapping images of yourself, as if you were inside an endlessly looping mirror maze. In this region, all light is destined to fall into the black hole. At this point, the black hole occupies most of your field of view, like a massive abyss about to swallow you whole. You glance at your watch once more, and find the time difference has stretched to a staggering 24 hours. As you draw ever closer to the black hole, people on the spaceship will see you falling more and more slowly, until you appear forever frozen at the edge of the black hole. Because the light you emit takes longer to escape, the light received by the spaceship slows down, until it disappears completely. So for the spaceship, they will never witness the moment you cross the event horizon. But for you, just seconds after entering the photon sphere, you will pass beyond the black hole's horizon. From this moment on, the world outside becomes your past. Everything about you will have no further connection with this universe. Even if you try to send signals outward, they will never reach their destination. And the path toward the singularity will become the final fate of all matter after crossing the event horizon. Soon you will feel an unimaginably powerful force tearing at your body. In the final moment before you lose consciousness, you will see your body land on the flat surface of a black celestial object, and in a fleeting 0.1 seconds, all the particles that make up your body will enter the black hole's core, merging with the black hole, becoming a part of it forever, and drifting alone through the cold and dark universe until eternity.